So today we will learn about binary search. It is an searching algorithm in which we search an element in an array. So why do we use binary search? We already have a linear searching algorithm, but we use binary search because it is more efficient, but it comes with a drawback that we can only use it when the array elements are sorted. So there are two things. It is efficient, but it can only be used when the array elements are sorted. Now coming to how the algorithm works. So let us suppose we have an array here uh, with elements 1, and we want to see how we can use binary search here. So well, we cannot use here because this is not a sorted array, so we will not be able to use binary search. But if it were a sorted array, and now we are tasked to find the target element, let us say 3. So we know that we have to find in this array, so our starting point will be this index and end point will be this, and now we will check the middle element. I think this is the middle. So if our middle element is equal to target, then and there only we will return, if they are asking to return the index or true or false, anything, then and there only we will return. But if it is not equal to target, then we will see that this element here, middle element, is greater than target, and we also note that the array is sorted. So by this we can come to a conclusion that since the array is sorted, so all the elements after this will be greater than this, and this element itself is greater than target. So that means our answer will lie in the left half of the array. So we will totally eliminate the right half, and from now we will search our target only in left half. So we will initially our right index was this. Now we will update our right index to this mid -1, and left will remain the same. And in this array again we will check the middle element. So if this is the middle, so now we will see that the middle element is definitely not equal to target, but it is smaller than target. So which gives us the idea that the target will definitely lie on the right half. So we will eliminate the left half, and now we will search here. Our mid element will be this, and yes, so then we can return the answer. So there are basically two components to this algorithm. First of all, we compare the middle element according to our need, and then decide which half to eliminate and which half to search further. So yes, this is the basis of the algorithm. So this is basically what binary search is. Now let us see the implementation of the algorithm, how we really implement it in the code in Java. Let us read the question. So this question says that you are given an integer array nums which is sorted in ascending order, and we need to find this element we need to return the index of this target element if it exists, and if it doesn't exist then simply return -1. So let us first of all take the length of the array. So this isn't sorted array and we need to find this element. So our search space is this whole array. So the starting point will be this index and the ending point will be this index. Between these we will find our element. So int left equal to 0. We will start from the beginning and search till the end, and right side is length of array -1 because we are considering index here. Now we will search in this until there is no element left to search. That means this is our left pointer, this is our right pointer. Till they collide we will search. Let us suppose this is left and at some instant this becomes our left, this element, and this becomes our right. So then also we can search, but if they cross each other then we cannot search because there will not be any valid array. So we will use this condition while left is less than or equal to right. Now we will check if middle element is equal, greater or smaller. This way we can get the middle index. Now we will check if the element at mid index is equal to target which we are searching here, then we will simply return that index. Then we are simply returning the index, and if the element, the middle element, is greater than target, so here let us say the target is 9 and this is the middle element, this or this. Okay, so if this is the middle element, so we see it is smaller than target. So all the elements which lie on the left side of this will definitely be smaller than 3 and hence definitely be smaller than 9, which is target. So we will eliminate this side and only search in the right side. So now what we have to do, this was our left, this was our right. Now we only need to search in this array, this array. So we will update our left from here to here. So now our left pointer will be updated. Left will become equal to mid +1 because now we are eliminating this side. We will only search in this array. So our left will become this and right will be the same. But if the middle element is smaller than target, okay, this has to be smaller. I explained it for smaller. Yes, and if the middle element is greater than target, so then we will know that our answer will lie on left side. So we will shift our right pointer just before the mid -1. And even after searching the whole array using our algorithm, still we didn't find the element, then we have to return -1. Let us run this code. So test cases are passing. Let us submit. Yes, so it is getting submitted, and this is the basic binary search algorithm. There are two components to it. First is deciding the range, and the second is the comparison. Like first we compare and then we decide which side of the array we will eliminate and which side we will search. Yes, so key components are comparison and range adjustment. Now talking about time complexity of binary search. This is the main reason because of which we use this algorithm. Let me explain. Yes, let us say we have an array of length n, and and it is a sorted array, and we are using binary search to find some target element. So in the first step, we will divide the array into half as usual, and then maybe we will not find our answer yet. So in the second step, we will again divide the previous half array into again half. This was our previous length, and then again to half, and we will continue this till we get our target, or in the worst case, if the search length gets exhausted. So here we can see that we are dividing n this many 2 times, and at the end the length will become equal to the length of the final array after k divisions with 2 will become equal to 1. So from this we can see that n will be equal to 2 to the power k, and now and remember, k is the number of times we are halving the array. We are dividing the array into half, so k is the number of iterations. So k will give us the time complexity. Now if we'll take log 2 on both the sides, we will get the value of k equal to log base 2 k, and n, and k was our number of iterations in the worst case. So like this we can see that the time complexity of binary search is log n. And yes, it has in real life, for let us say we have a very large database which is in a sorted manner, and every time a user search something, then we have to search in that database. So we can use there also we can use binary search. It will reduce the time for user to search anything that is searching. And now let us see some problems. This one we already did. Okay, so you can read this question. This says that we have a sorted array which may have duplicate elements, but it is sorted in non-decreasing order, and what we need to return, we are given a target element, and we need to return the starting index and the ending index of the target element. Let us say here we have target as 8, so we need to return the starting index of 8, which is 3, and the ending index of 8. Similarly, here the target is 6. So if the element is not present, then we have to return -1 and -1. So think how you will solve this using binary search, because using linear search we can solve, but the time complexity will be O of n. But here it's given, can you solve it in log n? So let us see how we will solve this using binary search. Okay, so first of all, let me take an example. Yes, so if we are given this array and they are asking this same question and the target is 3. So if we this is the starting point, this is the ending point, and if we will take the middle element here, which is I think this one, yes. So so now we see that the middle element is equal to target, and first of all we are trying to find the starting index of this target. So one thing is for sure, that if this middle element is equal to target, then it start maybe from here or maybe in the left side of the array. So we will mark this in our answer and then again search in the left, and later if we find any index before this which is of the same value as target, then at that time we will also mark it as start. But for now we know that the starting point will be this or in this side of the array. So first of all, let us find the starting point. Let me take the length of the array and let us take the start to be initially -1 and also -1. Now let us take our range. Int left equal to 0, right equal to the last index. Now till we are in a valid search range, check the middle element. If the middle element is, if it is greater than target, so if the middle element is greater than target, then we are sure to find target in the left side of the array. That means we will have to set our right side to mid -1. Or if else if this is not true, then check this. If nums of mid is smaller than target, then we are sure that the target element will be in the right half of the array. So we will update left to mid +1. Else, the case where the middle element is equal to target. So here we are trying to get the start index. So if middle element is equal to target, then set start to the index, and we are hopeful that we may find a lesser index in the left half. So we will update left. Now, if we are trying to search in left half, so we will have to upgrade our right index. So here we are trying to get the start index. Now let us find the end index. Let us again reset our range to 0 and write to the last index, and then we will have to do the same thing here again. Yes, so if it is not equal, then just eliminate one side and move to the other. But so here we are trying to get the last of occurrence of the target element. So if it is equal, then as if now make the end index equal to mid, and again we are hopeful that we may find a greater index than this in the right half. So update the left index. Now we will simply return the start and the end indexes. Yes, test cases are running fine. So this also gets accepted. Let us do the last practice problem of today's session. Yes, so in this question, if you will read this, they are saying that we are given a positive integer n and we need to find its square root, and if the square root is not a perfect square, then we have to take the floor value of that square root. So one thing is for sure, that the square root of n will definitely be less than n and will be some non-negative integer. So our search range starts from 0 and it ends at n minus 1, since the square root will be less than n. Now while we have a valid range, check that the element at mid position, at mid index. Now if the element at mid, if this mid square is equal to n, which means mid is a square root of n and it is also a perfect square, so straight away we will return mid as the square root. But if we will get mid square less than n, then so we need to return the floor value. So we will mark our answer as mid, and we will be hopeful that we may find any greater value than mid, which is a perfect square, or which is not a perfect square, but which gives the floor value. So we will now eliminate the left side of the array and search in the right side. So we will shift the range, and if this mid square is greater than n, then we will search in the left part. Yes, we need to declare answer first. Initialize. Yes, so let us try and run this. It is giving some error. Initialize. Okay, we need to initialize this also. Yes, so now it will get accepted, and this is some variation of it's just we talked that it has two components, choosing which half to eliminate, and the other was comparing. So here we are comparing the squares and square roots like this. So yeah, we have done the practice problems also. Now I will share this slide, but to get better at binary search, just go to LeetCode and start solving some problems. Start from easy, then medium, and then you can also try hard if you want. Yes, thank you.